Hi, and welcome back to another video with It's Dr. Dan, and today we're going to be looking at limiting reactants, or also known as limiting reagents. So whenever you come across these in stoichiometry, this is always one of the trickiest problems that you come across. And how do you know when you're going to see it? Well, the whole idea is whenever you have specific amounts of each reactant, meaning that in your problem, all the starting ingredients have either grams associated with them or moles, and that they actually have defined values. So, why is that important? Well, if you have a chemical reaction, things can run out, and that's what this is all about: is what's going to run out first. So for this type of reaction, what we're going to be looking at is how we can relate that to a common analogy. So what we're going to look at is how stoichiometry can be related to food first. Okay, so when we say we're going to be looking at food, we're going to be looking at how stoichiometry can be related to making very specific amounts of different recipes. So stoichiometry is just like cooking. So if you're going to be going through a different baking exercise, reactants are just like individual ingredients. So let's make a cake. Let's actually go through that entire process and actually see how we can relate different chemical reactants to something as simple as making food, which all of us do on a regular basis. So if I'm going to have a cake recipe, let's say if I have the following one. So I have flour, one flour is going to be mixed with 3 eggs and 2 milk, and that's going to create one cake. And this is something that's very similar to a chemical reaction. So if we wanted to write this out as a chemical reaction, we could do that. We could say, okay, we have one flour, and that's going to be combining with 3 eggs, and that's going to be combining with 2 milk, just like you would write out any set of coefficients with a chemical reaction. So this is all the same. So whenever you have any type of chemical reaction, it's the same thing as baking. So whenever you are trying to bake at home or if you're trying to cook, well, there's always certain things that you tend to run out of first, and a lot of times it's eggs and milk. So if we are to try to make this, well, let's say I open my fridge and I have all these different chemical reactants available to me. Well, and I want to be able to make as much cake as possible because that's something that, of course, we all want is something very, very sweet and really enjoyable. So if I have all these pieces, well, how can we try to look at this? Well, the whole idea is to try to figure out exactly how many cakes you can make. And being that we have a specific recipe here, so we have one flour combines with 3 eggs with 2 milk makes one cake. Why don't we try to see if we can do that? So if we take our ingredients and move them around, so why don't we have our one flour that combines with 3 eggs, and that's also going to combine with what, 2 milk, and that's one individual ingredient. And then we also can combine this over with another one as well. So one flour, 3 eggs, 2 milk, and that all combines as well. So why don't we move all this over a little bit? It all fits. Now, what's left over here? Well, if I try to make a third cake, notice how I'm out of milk and I have excess amounts of both flour and eggs when trying to write all this out. So if we try to sort everything here into its individual columns, well, if I count all the original starting ingredients that I have here, well, you could see that, okay, we had 4 milk, we had 10 eggs, and then we had 4 flour within this particular, what was in our kitchen. Now, in our recipe, we can only make so much because certain things ran out. So once we sorted everything into how many cakes we can make, well, this is a limiting reagent problem. One thing that you saw is that the milk, it runs out by the third cake, meaning that milk in this situation is referred to as a limiting reagent. So what is that all about? How can we define that? Well, a limiting reactant is whatever the first reactant that is used up first. We whip up 2 cakes as a result, but we still have a lot of leftover ingredients. So limiting reagent, once again, is the first reactant that's used up. Milk in this situation ran out. By the third cake, we did not have any milk left over. It all ran out. It was used up. Now, when that happens, when the limiting reactant is used up, the reaction stops, meaning we can't go any farther. The reaction completely stops. So when we whipped up our first 2 cakes, we can't go anymore, even though we still have eggs and flour left over that are ready and willing to be made into something delicious. There is no more left. So in this situation, the limiting reactant is milk. And this is how you're going to be defining this in different chemical reactions. So limiting reactant is milk. Now, what other definitions that are very crucial? The excess reactant is what is left over after the reaction has already stopped. So after we got to the second cake, the reaction stopped because we ran out of milk. Now, being that that completely stopped, that means the limiting reagent was all used up. Milk was gone. So we had excess or leftover amounts of flour and eggs left over. So in the end, we had the excess of 2 flour and an excess of 4 eggs as a result. Now, is this something that we can always try to relate this to? Well, we're not always going to be sadly cooking in chemistry class. So a lot of times we got to actually show this with different chemical reactions and different chemical species. So being that that is said, why don't we go back to the stoichiometry side and show how we can relate this to specific amounts of each reactant. Back to chemistry. So now that's all done, now that we made our cakes, let's try to relate how much of a, instead of a specific ingredient, how much of specific reactant we can do in all of our different ingredient in our different recipes. So if I have, instead of a recipe, I have a reaction. So if I have the following one, it says a reaction creates methanol, which is CH3OH, from carbon monoxide and hydrogen gas. There are 3 moles of CO and 8 moles of H2. What is the limiting reactant? All right, so this is going to be very similar to our cake recipe. How do we go about doing that? Well, the very first thing that we did is we had to lay out our recipe, aka our chemical reaction. So our first step is what we're going to be doing is writing our balanced chemical equation. Now, this might require a few skills that you may or may not be comfortable with at this moment. If that's the case, please try to review the following. So a couple little notes here is make sure you're comfortable with reading chemical names, because that's very common in general chemistry, is that you have to be able to convert from a name to a formula. The other thing is with names is that you might have to swap drop, meaning if you have an ionic compound, you have to make sure you know the balanced charges, so that way you can properly balance your chemical equation. You also might need to be able to predict the reaction as well. So keep in mind that there are a lot of little tips that you can have, and I have videos on every single one of these. I would highly recommend checking them out to be able to brush up on those skills. Now, being though that this particular chemical equation, it is mentioned in the problem. So it's telling us that we are creating methanol as a result. So when we are actually making methanol, all right, that's telling you that is your product. So let's write that out. So our product in this case is going to be methanol, so CH3OH, and it's being created with carbon monoxide and H2. Now, when we have this formula, is it balanced? And one thing you can probably see really quickly is that, okay, well, we have 1 carbon on each side. Those are balanced. We have 1 oxygen on each side. Those are balanced. However, the hydrogens, there's four on the right-hand side and two on the left-hand side, right? So how can we easily balance that is we can add a 2 here, right? And now what is that exactly showing? Well, it's going to show something like this. So this is what it's going to look like. It's going to have the following chemical reaction here. So being that we have one carbon monoxide reacting with two hydrogen molecules, that's going to be creating one methanol. So it's very similar to our recipe. This is the chemical reaction we were going to follow. So being that we were given a bunch of starting ingredients, we can do some little mole to mole calculations to try to solve for what is going to be running out in our chemical reaction. So let's try to figure out, using the amount of each given reactant, how we can calculate how many moles or what the amount of each product produced is. So if I have my chemical reaction, right, we can see that for every 1 mole of CO, we have 2 moles of hydrogen. Also for every 1 mole of CO, we create 1 mole of methanol. So with all that starting information, we were given that we had 3 moles of CO and 8 moles of hydrogen that were going to be in this reaction. So with that being said, let's bring that down. So we had 3 moles of CO, and then we also had 8 moles of hydrogen. And our idea is here is we want to see is what's going to run out first. So what we can do is we can set up our little conversion table for ourselves to see exactly how this is going to run out, just like our cake recipe. So in our reaction, what we have is that for every 3 moles of CO, for every 1 mole of CO, I have 1 mole of CH3OH that is being created. And the way that we're seeing that is by looking directly at the recipe. So we have 1 mole of CO is creating 1 mole of CH3, meaning that when I convert this, we do 3 times 1 mole of CH3OH divided by 1 mole of CO, and what we will get is 3 moles of CH3OH is created. Now, what this represents, the story behind this reaction is, if all the 3 moles of CO was used completely, this is how many moles of methanol we would make, or aka how many cakes are we making in this recipe. Now, what we're going to do is we're going to do the same thing with H2. So if I have, reading my recipe, I have 2 moles of H2 are equivalent to 1 mole of methanol, meaning that for every 2 moles of hydrogen that react here or are baked, we create 1 mole of methanol. So with that being said, what we can do is we can summarize this chemical equation. So what do I mean by summarize? Well, what we're going to do is we can take 8 times 1 divided by 2. So if we do that, what we're going to see is we're going to create 4 moles of CH3OH in our reaction. And notice how when we do these two problems, our units are canceling out. We're matching up all of our units. Now, what do both of these numbers tell you? So the first time I said that if you use up all 3 moles of CO, we create 3 moles of methanol. The second one tells you if you use up all 8 moles of hydrogen, we create 4 moles of methanol. So what that tells you is what is going to run out first. Well, being that when we use up all of the CO, we create less methanol, this is going to run out. So as a result, CO is our limiting reactant or our limiting reagent. So being that that's our limiting reactant, also it might be abbreviated as LR. What is happening here is hydrogen is going to be in excess. So your last step here is identifying the limiting reactant, why is that important? Well, so carbon monoxide is our limiting reactant. And like we mentioned, H2 is in excess, meaning that there's going to be leftovers. So whenever we are doing these types of problems, there's a couple other little tricks that we can do as well. So depending on what problem you're presented in your chemistry class, you could be asked some of the following questions. Some of those could be, how much is left over? Calculate it. How much of that excess reactant was used? So how much was required to go through that specific reaction step? Or maybe you have to do some further stoichiometry and figure out the mass, maybe the volume, or a couple different things like that. So why don't we try and show one or two of those examples? So if I had the following information, we know that CO ran out first. So the limiting reagent is what governs how much excess is left over. So being that we know that we used up all 3 moles of CO, we can use that to figure out how much hydrogen was used. So if I set up that same chemical equation, so 3 moles of CO, and what we want to do is figure out how much of our hydrogen was actually used. So in our original problem, for every 1 mole of CO, we used 2 moles of hydrogen to react. So when we do that math here, we can see that in the reaction, it reacted with a total of 6 moles of H2. So this is how much was used in the reaction. So if we wanted to figure out how much was left over or how much is in excess, well, excess is always going to be the initial minus what is used. So in this case, being that we started with 8 moles of hydrogen, we are going to subtract that from the 6 moles of hydrogen that was used to figure out that, oh, we're going to have 2 moles of H2 left over. So the whole idea is that when you have this excess or leftovers, it's the same thing going back to our cake analogy from earlier. So in the original problem from the beginning, right, we had essentially 4 moles or 4 eggs left over. And we also had two moles or 2 things of flour that were left over, and those were in excess. But when we looked at what was used in this reaction, if we kind of go back to our original recipe, well, you know that for every 3 eggs were required for each of these 2 cakes here. So that means that 6 eggs were used. Or if we look at the flour, well, we know that 2 flour were used. So it's all about the same type of information that is being used within the problem. And that's all about how do you look at it. Now, when it comes to the last step with stoichiometry, this is really where limiting reagents can get complicated and what's going to lead to further videos. So depending on really where this video was focusing on was right here in the middle. The goal is always the mole, meaning that we have a chemical equation or a recipe, and we're converting it from moles to moles. And that will reveal the limiting reagent. Now, a lot of problems you might have to calculate the grams that is required, meaning you have to use molar mass to do that. Or if you have a solution, you might have to use molarity to get to that point. Or if you have a gas, you might have to use the ideal gas law to get to liters. So it all depends on what type of problem you're being presented. But the entire idea is to see is what exactly ran out first in your little recipe when you were trying to bake your little cake or try to figure out your chemical reaction. This has been limiting reagents, and there will be future videos going through more examples of these and also going through the different types of stoichiometry. There's already one video posted about mass to mass. There's going to be more coming soon, so please feel free to like and subscribe, and I hope to see you back for future videos. Thank you so much for watching. Bye now.